In this problem we have a vector u, which is going to be the limit of another vector, a vector v, which is going to be the integral of another vector, and in the end we want to find the dot product between u and v. So this is more of mini problems. We have three mini problems for the vector u, 3 mini problems for the vector v. And so they're all sort of Calc 1 in nature, maybe Math 103 and Math 104. And so let's take a look at the first one. The limit as t goes to infinity of e to the minus t. As t goes to infinity. Well, as t gets very large, if we think about e to the minus t as, if we think about this as 1 over e to the t, then that helps us see that then t gets large, the denominator gets large. 1 over a very large number is a very small number. That's going to go to 0. That's our first component of u. Second component of u, t is going to infinity again, and we're looking at a fraction, negative 2t over t plus 1. And what we're going to do with this one is use L'Hopital's rule. This would be negative infinity over infinity. And so we take the derivative of the numerator, the derivative of the denominator, and trade our limit in for that, using L'Hopital's rule. And so we get limit as t goes to infinity negative 2 over 1. And so second component of u is negative 2. Third component is going to be found by finding out what happens to arctan as the variable gets very large. So you just have to know the nature of the arctan function, that it has horizontal asymptotes, and the one we're interested in, as t gets very large, arctan goes to pi over 2. It's the inverse tangent, and the graph of it quickly looks like this. As we get very small, it approaches minus pi over 2. As we get very large, it approaches pi over 2. This is a quick sketch of arctan. Okay, good. And so that's the vector u. Then we have the vector v, which is found from integrals. We have an integral from 0 to 4. I'm sorry, 0 to pi over 4 of secant squared. Well, what function has secant squared as its derivative? That would be our antiderivative we're in search of, and that's just tangent. And so we just have to tangent of t, evaluate it from 0 to pi over 4. Tangent of pi over 4 is 1. Tangent of 0 is 0. And so the first component of v is 1, but we actually don't even care because it's going to be dotted with u, and the first component of u is 0. So actually we could have not even done that part. Save ourselves some time. Next up, we're going to integrate negative 2 times the cosine of t. Well, I'm sorry, not limit. Integral negative 2 times the cosine of t from 0 to pi over 2, pi over 4. What function has negative cosine t as its negative 2 cosine t as its derivative? It's going to be negative 2 sine of t. And so we just have to evaluate that at upper and lower limit. And what we'll find out is the lower limit is 0 again. Sine of pi over 4 is root 2 over 2. So we have negative 2 times the quantity root 2 over 2 minus 0. So we get negative root 2 for the second component. Then the third is, oh, that's just minus 1 from 0 to pi over 2. The integral of 0 pi over 4, sorry, I keep saying pi over 2, of negative 1. And so that's just going to be negative pi over 4. That's t evaluated from 0 to pi over 4. So we get that. And now we're ready to do the dot product between the two vectors. And so the dot product between u and v we take and multiply the 0 times the 1 and get 0. We multiply the negative 2 times the negative root 2 and get 2 root 2. And we multiply the pi over 2 times the negative pi over 4 to get negative pi squared over 8. And then we match it to one of the multiple choice answers. It's looking like letter B. Yeah, 2 root 2 minus pi squared over 8.